Welcome everyone. Today we are going to explore the basic structure of programming in C and C++. If you have never written a line of code before, do not worry. We are going to build your understanding from the ground up. By the end of this session, you will know exactly how a program is organized and why this structure is so incredibly important. Now that we know what we are covering, let us understand why structure matters. Think about writing a formal letter. You have a sender's address at the top, a greeting, the main body, and a signature at the bottom. If you mix these up, the recipient gets confused. Similarly, a C or C++ program has a strict, predictable layout. This structure acts as a universal blueprint. It tells the computer exactly where to find the setup instructions, where the actual program begins, and where it ends. Without this rigid structure, the computer would not know how to read your code. Before we look at the code itself, we must understand how your text becomes a running program. When you type code, you write in a high-level language, which is easy for humans, but impossible for a processor to read directly. To bridge this gap, your code goes through a multi-stage pipeline known as the compilation process. This pipeline translates your human-readable text into machine code, which is a raw series of zeros and ones. The preprocessor handles the setup, the compiler does the translation, the linker connects system libraries, and finally, the processor executes the program. This flowchart visually represents the journey your code takes from the moment you finish typing to the moment the program actually runs. At the top, we start with your human-readable source code. It flows down into the preprocessor, which gathers any external files you requested. Next, it moves to the compiler, which translates your text into machine code made of zeros and ones. Then, the linker connects your code with built-in system libraries. Finally, we reach execution, where the program runs. Understanding this pipeline helps you figure out exactly where an error is coming from. Now that we understand the pipeline, let us look at the very first part of our code structure. The very first lines of almost every C or C++ program begin with a hash symbol, such as #include stdio.h. These are called preprocessor directives. Think of this like telling an assistant to go fetch a specific reference book and put it on your desk before you start writing an essay. When you write include, you are telling the preprocessor to find a specific file, like a dictionary of standard commands, and paste its contents directly into your program, behind the scenes. After the preprocessor sets things up, we reach the core of our program. Every single C and C++ program must have a section called main. This is known as the entry point of your program. It is the exact spot where the computer starts reading and executing your instructions. Think of the main function as the front door to a massive building. No matter how big the building is or how complex your code gets, you always have to enter through the front door to get inside. Without this entry point, the computer simply does not know where to begin. Once the computer enters the main function and runs your instructions, it needs a way to finish. At the very end of this main section, you will almost always see the statement return 0. This statement is a direct final message to the computer's operating system, such as Windows or macOS. It tells the system that the program has finished its job successfully. Returning a 0 means 0 errors occurred during the run. On the other hand, returning any non-zero number, like a 1 or -1, acts as an alarm bell, telling the operating system that the program crashed. Let us see this structure in action with the simplest possible program. We will build it step by step. Line 1 is our preprocessor directive, fetching the standard input-output library so we can print text. Line 2 opens the front door with int main, and the opening curly brace marks the start of our instructions. Line 3 is the actual instruction, telling the computer to display hello student on the screen. Line 4 is return 0, telling the operating system we finished with 0 errors. Finally, Line 5 is the closing curly brace, which officially ends the program.
Now that we have seen a basic greeting, let us look at a slightly more complex example, where we use this structure to perform a mathematical calculation. We want to calculate the area of a rectangle. Just like before, we absolutely must start with our preprocessor directives and our main function. Without them, the computer will not know how to start or how to print the answer. Inside the body of the program, between the curly braces, we will use a basic geometric formula to find the answer. Let us look at that formula next. Here is the formula we will use inside our program. A equals L times W. In this formula, A represents the total area of the rectangle, L represents the length, and W represents the width. By multiplying the length by the width, we find the total space inside the shape. If either the length or the width increases, the total area will also increase proportionally. This is a standard mathematical rule that we are simply asking the computer to process for us. Now, let us apply this formula in our code. Let us solve this step by step, just as the computer would. We are given specific values for our rectangle. The length is given as 5 units and the width is given as 4 units. Our goal is to find the total area. To do this, we substitute our known values into the equation we just discussed. The computer will process this exact multiplication inside the body of our main function. We do not have to do the math ourselves. We just have to provide the correct instructions in the correct order. Continuing with our calculation, we set up the multiplication as A equals 5 times 4. Inside our C program, we write our math instruction, tell the computer to print the result, and then write return 0 to signal a successful finish. The computer evaluates 5 times 4 and the final result is 20 square units. Notice that the basic structure of the program remains exactly the same as our first example, no matter what mathematical operations we put inside the body. So, why does all of this matter? Understanding the basic structure of a program is like understanding the foundation and framing of a house. In the real world, software engineers work on programs that are millions of lines long, such as web browsers, video games, or banking systems. Despite their massive size, every single one of these complex systems relies on this exact same basic structure to function. They all have a main entry point, and they all communicate success or failure back to the operating system. Let us review the key takeaways from today. First, C and C++ programs rely on a strict universal blueprint to function. Second, your code goes through a compilation process to become machine-readable. Third, preprocessor directives like include fetch necessary tools before the main compiler starts. Fourth, the main function is the absolute entry point where execution begins. And finally, returning 0 tells the operating system everything ran perfectly. You have now mastered the skeleton of programming, giving you a solid foundation for all your future code.